we go. Live in a few moments. And we are... Go! What's up, Hacksters? So, our Secure Everything with Azure Sphere contest with the Azure Sphere kit from Microsoft and Avnet is wrapping up pretty soon here. Submissions close in 17 days. And we think some people still may be stuck on what to build for their project or how to go about that. And soon we're going to do another video on common questions that you might have about how to set up your kit and how to get your project running. In the meantime, just in case you're still in that deliberation stage where you're like, you know, I've got like 3 or 4 ideas I'd like to build, but maybe I'm not sure which one is easiest or most realistic or most useful. Anyway, we've got some suggestions from projects that are already published to sort of get your mind flowing. If mine's actually flowing, that might be a bad thing. Obviously, you don't want to build these same projects, but it might be helpful. So first up, we've got from Anime Mecha, and a very mechatronic way of growing your own crops indoors using Azure IoT Central. This person lists out the benefits of using the Azure Sphere for a project like this, including, so basically they want to run a grow light for about 10 hours. With that time being adjustable, it should water the plants automatically, but not every time the moisture sensor senses that the soil is dry. It should be every few days at most. That also should be adjustable. And they really want security, because what if someone gets hold of your credentials for your watering system and decides to just flood your garage or wherever you have this? That would also be not optimal, and ideally they'd be able to scale it as well. So as a result, they've got this awesome project that publishes data to Azure IoT Central, and you can see what exactly they're publishing in here and how to input that if you're building the system yourself, which could be adaptable to all kinds of things. Like, I don't know, you could do a pet food dispenser or something like that as well. I could easily see a system like this controlling multiple dog or cat or fish or bird or whatever food systems and water systems for them as well. You see how to program the Azure Sphere and modify the code for that. And then they tell you how to mount the click relay onto the board itself. So they're using this relay click board from Microelectronica, and you can see it in the picture here, along with the peristaltic pump that they're using to water their plants. And they've made this whole little enclosure for it. In the end, they mounted it kind of ingeniously on top of this walker here, so that there was a shelf down there underneath on sort of a little step table, I guess, for the module, and then on top they have the grow light that it's controlling. And you can find the code below, and yeah, a super inspiring project that I think could be adapted to a number of different applications. Next up, we have the Azure Sphere weather station. Speaking of, in case someone gets hold of your system controls and is able to flood your garage, which hopefully with the Azure Sphere wouldn't happen, but just in case, here is a I think it's got a moisture sensor on it. Yeah, a water detection clickboard. So, you know, you could put this in your garage with the other one so that you'll instantly get an alert if someone does start flooding. I mean, it shouldn't happen anyway, but yeah. This one also uses an environmental clickboard. And it's a little weather station that reports data to Azure IoT Cloud, the Azure IoT Hub, my bad, in the Azure Cloud Console. And Evan here is really, really comprehensive in everything you need to do to figure out how to configure the sensors, how to pull their data into the code, and how to upload them to the cloud. Also, at the end, there's some musings on what could be done to take this project further. So, for example, I'm planning to create a project that displays this data in real time via a local dashboard. A separate IoT device could then check if the conditions are getting too hot or dry and water the plants accordingly. It could also send out alerts if it senses that there are too many VOCs or volatile organic compounds in the air, which could indicate a possible respiratory hazard, something that's very useful to us here in California. So that is by Arduino Having 11 guy. Awesome. As always, you'll find the links to these projects in the description of the video. Another cool IoT project here, using a different board, the Air Quality Click, speaking of which. This one also sends data to IoT Central, and it just uses a different type of sensor, the SGP30 sensor. And they've developed their own driver for it. It says, now we know what the sensor does and what protocol we'll use to communicate with it, but how can we do that? We will use the project provided by Avnet in GitHub. This repo has 2 projects we will use because it's necessary to use the I2C protocol and send data to Azure IoT Central. And I think he's going to publish it to GitHub. Yeah, here we go. Walter has published his own version of the code to GitHub, so you can find that at the bottom of the project, as always. And you can see that you get this air quality sensor data displayed in a beautiful little graph. It's super useful and easy to check. Now, this next one is pretty cool. Ivan won an award, actually, an impact prize in one of our contests for IOTA, which is a distributed blockchain system. So, in this case, IOTA is not being used to store value. Instead, the blockchain is being used for security, to be able to securely share health records across different systems. Even within the same hospital, it turns out. Ivan encountered this issue where they wouldn't necessarily know what sorts of tests were run or data was acquired from another department, because their systems were so disparate and not connected. And part of that is just security, you know. They don't have the best systems, and so instead of compromising the security, it just isn't linked together. So this is based on, actually, it was inspired by some personal experiences that Ivan had, and it's an incredible story. If you want to learn more about this, I would recommend checking out our video interview that we did with Ivan about the project. He's got, incidentally, an amazing maker cave. Look at this. It's incredible. I'm jealous. Like, I've got these walls. I've got kind of a cool, like, sticker wall and stuff here, but look at it. Look how organized. I'm so jealous. Anyway, it doesn't go to waste. He has this incredible project and uses and shares all this information about how to build it, working with the Microelectronica heart rate clickboard. So as you can see, all these people are using different clickboards to accomplish different things. And you can very easily learn from them. If you want to use a different type of clickboard, it should be pretty easy at this point to adapt your own project to that. And you have 17 days, so hopefully you'll be able to get hold of whichever clickboard you need and be able to adapt it with relative ease. Then he goes into the Azure IoT Central application, telemetry, Azure functions, and yeah, all kinds of information here. The results of what the project does, and I think he also talks about the future. So much stuff. Lessons learned, pardon me, limitations in the technology, and what might happen and become possible with full-scale deployment of this technology if hospitals were to adopt it in a widespread fashion. What this would enable for us as patients and for healthcare providers all over the world. Like, it'd be pretty incredible. You could maybe even go to, other countries and receive the same standard of care, or receive, people who know what your history is in a secure way because this system exists. And then you would be able to know what kinds of drug interactions to watch out for and things like that. So much stuff would become so much better. Really inspiring project by Ivan there. And then finally, we have this paper coffee project by Louis Freiberg. It is a hacked Nespresso machine that detects when a new transaction comes through on IOTA again, and allows you to have coffee. As you can see in this image here, it's a 3D printed module. If I scroll this way, this right here is a 3D printed module with an e-ink display that will show you, I think it's got a QR code that shows you how to pay. Yeah, here we go. Send 100 IOTA to this address for a coffee. Very cool. And then this gets embedded in a little 3D printed module that goes on top of the Nespresso machine. You can find info about the prototyping for that. I love seeing all the iterations someone has gone through in order to create a project. Ah, so cool. Instead of waiting for a new PCB, I chopped off the relay circuit from a spare door phone mod I made earlier. What? And then all the hacks made on the Nespresso machine itself. Secured with washi tape, it looks like. So stylish. And this project also has a ton of humorous and relevant GIFs, which is always fantastic. Come at me if you use a different pronunciation. I'm ready. So yeah, it includes the 3D printable parts as well as the code for the ESP32, all kinds of stuff to help make this possible. You know what? This might not actually be an this is very embarrassing. I'm not sure this isn't actually an Azure Sphere project. Somehow I thought that it was. Anyway, maybe I'll cut that part out of the recording. In the meantime, it's still a cool project. It uses the IOTA tangle. It's relevant because of the health record system. And sometimes maybe I need to check my facts before I get on the air. Let's take a look and see if there's any comments that have anything to do with stuff that isn't mocking me for making a mistake. Once more, the projects we talked about are growing crops indoors with Azure IoT Central, Azure Sphere Weather Station, using the moisture detector and environment clipboards. We've got the air quality sensor, the Azure Sphere and Microwave Air Quality Sending to IoT Central project by Walter. And then from Ivan, we've got the distributed health record using IoT and IOTA on the Azure Sphere with the microelectronica heart rate sensor click. Plus, check out the interview with Ivan, super cool. And if you're curious about IOTA, check out this paper coffee project, which is also cool and inspiring. Maybe you could be the one to make the very secure coffee dispenser. There's even, already some updating that's worth doing with this one from Louis because apparently you still have to load the Nespresso module, the little capsule yourself. And so you could make the entire system robotic and contribute to science and humanity in that way. And maybe if someone had made me a robotic coffee machine, I would have been awake enough to notice that that's not an Azure Sphere project. Still cool. Still hope that you get your projects done and everything you dreamed of. I want everyone to achieve their dreams. And let's see if there's any questions. David says, I was trying to get into it, but the requirement for microbus clipboards makes it a little difficult from a pure experimental perspective. Cool boards available, though. This is true. I think that maybe some other people also have been running into issues with integration. And so hopefully seeing all these different projects with the clipboards will enable you to be able to get over that hump and be able to integrate your own systems completely. Joey says, I might have to get in on this contest. Please do. That'd be awesome. Martin says, hey, you can send your coffee consume live to Facebook. How great is this? It's pretty great. I've got some tea here currently because it is 10:16 p.m. If I had coffee, I'd probably be oscillating, resonating right now, and you could probably hear like a humming noise. Probably about like 400 hertz. That's why I stick to tea. But yeah, have an awesome rest of your Wednesday night. We will see you soon. I'm going to be at Hackaday SuperCon this weekend. Check out my talk with Odd J about companion robots. Yeah. And yeah, we'll see you soon. Hack on.